Hello everyone, welcome to Distinction Learning Platform, and in this video we'll look at errors and approximation. Okay, look at error and approximation. Okay, so error and approximation, it is a wide topic, but in this video our main focus will look at how one should be able to find the absolute error, how one should be able to find the limits, the tolerance, the relative error, as well as the percentage error. Okay, so I'll start with how one should be able to know how to solve the absolute error. Okay, absolute error. Okay, great. So absolute error. What is an absolute error? So an absolute error has got different definitions. Okay, so I'll just give you basically two definitions. So absolute error, by definition, this is the half of the least unit of measure. This is the half of the least unit of measure. So absolute error by definition, okay, this is the half of the least unit of measure. Okay, like that. So from the definition of absolute error, okay, we can be able to come up with the formula to say absolute error is nothing but equal to half, which is 1/2 multiplied by the least unit of measure. Least unit of measure. So this least unit of measure, it is also known as the what? Tolerance, which I shall explain later on in this lesson. So now, one thing which you're supposed to know is that the absolute error is basically half of the least unit of what? Measure. Another definition for the absolute error is the difference. This is the difference. This is the difference of the, okay, this is the difference between their recorded measure or value and their true measure, true value, or true length. So the difference between the recorded measure and the true measure is basically what is also known as the what? The absolute error. Therefore, from here we can be able to come up with the formula. Yes. So absolute error is nothing but equal to the modulus of the recorded measure. You know, when we say difference, what should come into your mind is what? A minus. The true measure. Like that. Yes. Great. Like that. So why putting the modulus bars? So the reason as to why we are putting their modulus, bars is that when you are measuring, distance, okay? Distance is a scalar, okay? Distance is a scalar, and it can never be, a negative. So if I put the modulus bars, this implies to say sometimes, when I'm measuring something and I want to find the distance, okay, I can be given to say the true value of, for example, say a book is maybe 20 centimeters, okay, and then I'm given that book and I'm told to take the measurement of that book, and I find that my recorded, so this is the true measure, and my recorded is maybe say 18 centimeters, like that. This is in my recorded, when in the actual sense I was given the book measured 20 centimeters. So if I were to find the error, there is an error there called the absolute error. How do I find this error? So I am going to say absolute error is equal to what? The recorded measure, which in this case it was 18, minus the true measure, which was what, 20. And note that here I'll get -2. Remember, I'm dealing with centimeters. I want to find the distance, and I'm finding a negative number. So this implies to say the answer is what? Wrong. That's why we are putting these modulus bars to imply to say if I were to, -2, the modulus of this number, it is always what? Positive. Okay, +2. So always know that the absolute error, okay, you always get a positive value by putting the modulus bars. Thank you. Great. So now let us look at another aspect. Okay, let's look at another aspect. So in as much as I've talked about the absolute error, so now the question is, how do we find this same absolute error? Okay, so a good example, it can be, let me just draw a table. Okay, let me just draw a table. Okay, I've got I can say numbers. Okay, I can have numbers. Okay, I can have tolerance, which is the least unit of measure, and the other here I can have absolute what? Error. So why coming up with this table? I want to explain how to find the absolute error. So if on the numbers I'm dealing with a whole number, okay, it can be 1, it can be any number, okay, so long as it's a whole number. 10, it can be 200, it can be 1,000, it can be, so long as it's a whole number. The tolerance, or rather the least unit of measure, is always 1 for a whole number. Okay, it is always what? 1 for a whole number. Okay, so if I have a number, okay, we have a whole number, say this is a whole number 25, and it has got a decimal number. Okay, numbers after the decimal point are called decimal numbers. If it has got one decimal number, say 8, this is one decimal number. The tolerance, or the least unit of measure, is 0.1. Okay, if it has got say 2 decimal numbers, maybe say 172 point maybe say 5 6, like that. 2 decimal numbers, this is 5 and 6, so the tolerance is 0.01. so there's a pattern. If there were 3, 0.001. Correct. From here, how do I find my absolute error? It's very simple. So basically my absolute error, okay, I can use the formula, okay, to say in this case I have a whole number. It can be 25, it can be any number here, so long as it's a whole number. So how do I find their absolute error? It's very simple. I shall use the first formula to say absolute error is equal to half multiplied by the least unit of measure. For your number, the least unit of measure is 1 and the absolute error is 0.5. So this is 0.5. If I'm dealing with, I want to find the absolute error for a number, okay? It can be any number, a number, so long as it has got one decimal, one decimal number. It can be 10 point, any number like say 7. So my interest is in the number of decimal, numbers like that. So it's 1. So this implies to say the absolute error is equal to half. The tolerance is 0.1, which is, this is 0.05. So the answer should be 0.05, like that. If my tolerance is 0.01 and I want to find the absolute error for this number, okay, which has got how many? 2 decimal numbers, okay? If it has got 2 decimal numbers, what happens? So I'll say absolute error is equal to half 2 decimal numbers. The tolerance is 0.01, which is the least unit of measure. In this case, if I were to multiply this, okay, if I were to multiply this, I'll get 0.005. So it's a pattern like that. 0.005. If there were 3, 0.00, 3 zeros and a 5, just like that. So it's a pattern. That's how you find the absolute error. Great. Now, let me talk about something which is very important. I've talked about the absolute error. Yes. Maybe one might be wondering to say, what about this one? Well, where do one use it? Where are we supposed to apply it? So for the second formula, there is a situation whereby you've been given something, okay, to take the measurement of that thingy, of which in the actual sense, the measurement was assigned or rather given, and you find that you take a different measurement from what was given. Therefore, you can use this formula. Why? Because there is an error when you are taking the measurements. Yes, by simply saying the recorded measure, meaning the value which you had undertaken, or rather the value which you got when you measured that thingy which was given for you to measure. And the true measure is the one which is always given, and you can apply this formula. Yes. Now, let me talk about the tolerance. Okay? Let me talk about the what? The tolerance. Great. How do we find the tolerance? Great. Okay. Tolerance. Okay? So, basically, there is what we call limits. Limits is what we call limits. There is what we call limits. We have under limits, upper limit, and lower limit. We have upper limit and lower limit. Okay? So, when you talk about the limits, basically they have the formula. There's a formula that we use when we want to find limits. Okay? What's that formula? For upper limit, we use the formula true measure of value, true value, plus the absolute error. For lower limit, we use the formula true value or true length or true measure minus the absolute error, like that. So as you can see, the knowing how to find the absolute error is very, very important. Knowing how to find the absolute error is Very, very important. Yes. So that's how we find the upper limit and the lower limit. Great. And now the tolerance. The tolerance is basically the difference between the upper limit and the lower limit. So the difference between the upper limit and the what? Lower limit. So we have the upper limit minus lower limit. When you find the upper limit by simply saying true value plus the absolute error, when you find the lower limit, then you take their difference. You should be able to get the tolerance. Okay, so this is the first formula. Another formula, recall that when we are finding the absolute error, we said this is half multiplied by the what? The tolerance. If I were to say over 1, then I cross multiply. 1 multiplied by 1 is 1. Multiplied by the tolerance, I should be able to get the what? The tolerance. And this is nothing but equal to absolute. Okay? This is supposed to be E. So absolute error multiplied by 2, I have 2 multiplied by the what? Absolute error. Like that. So another formula, tolerance is equal to 2 multiplied by the what? The absolute error. Once you know the absolute error, multiply it by 2, you should be able to get the what? The tolerance. Great. Another aspect which is important is how to find the relative error. Okay? Relative error. Good. So relative error, this is the ratio. This is the ratio of the absolute error to the true measure or true value or true length. Implying to say relative error is equal to absolute error divided by true measure or true value. Okay, so this is the formula. Basically, relative error is equal to absolute error divided by the what? The true measure or the true value or the true what? True length. Yes. Another aspect which is very important is the percentage error. Okay, percentage error. Okay, and this should be the last. Okay, the percentage error. Okay, percentage error. Percentage error. Okay, so percentage error is the relative error. This is the relative error which is expressed as a percentage. This is the relative error which is expressed as a what? A percentage. So basically, percentage error is equal to relative error multiplied by 100. Okay? Percent. So now, the relative error we know to say is absolute error divided by what? True value or true measure multiplied by 100%. So basically, this is the formula when you want to find the percentage error. Now, so one should know how to find the absolute error. It's very, very important. 2, you should be able how to find the limits, okay? The upper limit as well as the lower limit. You should be able to know how to find the tolerance, okay? You should also be able to know how to find the relative error as well as their percentage error. Okay, and I shall show how one can be able to find their limits, the relative error, percentage error in their next video. Thanks for watching. Look for more videos.